Welcome to Spring LIB.
Actinium is a highly radioactive element having a half-life of 21.77 years. So using the model, we want to find the K value if it has a half-life of 21.77 years. That means when you divide by a sub 0, you get 1/2 times e to the K, and we know it took 21.77 years. So we take the natural log of 0.5. We take the natural log of both sides, but when we take the natural log of exponential base e, it just gets rid of it. And so then we just have 21.77k that you'll divide both sides of the equation by to get k. So it's the natural log of 0.5 divided by 21.77, which is negative 0.0318 to 4 decimal places. Suppose a scientist in the year 1880 collected 100 grams of actinium. How much would remain now in 2020? Well, that would be 100 times e to the negative 0.0318, and this would be the difference of 2020 and 1880 would be 140 years. And so 100 times e to the negative 0.0318 times 140 would be 1 point, let's see what I have here, to the nearest gram, 1 gram. Suppose a scientist in 1980 wanted to collect and store actinium and wanted to be sure to have 70 grams in the year 2020. How much should she store? Well, if we want to make sure we have 70 grams to finish, we want to know how much should we start with, given everything we know. It's going to be in 40 years. And so we would just divide both sides of the equation by e to the negative 0.0318 times 40. That's just going to get rid of it on the other side, and we'll be left with just our initial amount. So 70 divided by e to the negative 0.0318 times 40. We'll say to the nearest gram, 250 grams.